Yeah, Santosh, can we go live?
Sir, we're live right now. Can we start?
Yeah. Thank you. A very good morning to one and all present for this DAKSH Powertalk, which is going to be delivered by Professor V. Kamakoti, Director, Indian Institute of Technology, Madras, on a topic that appropriately resonates with the current context that is surrounding us. And before I lay down the context for the talk, let me at the outset, on behalf of the Shastra family, the organizing committee members of DAKSH and Kurukshastra, and on my personal behalf, welcome Professor V. Kamakoti for this DAKSH Power Talk session, and also congratulate him on assuming office as the director of IIT Madras. And for those who are familiar with Professor Kamakoti and his work, you are also familiar with the fact that he has also been instrumental in various progressive measures that Shastra has also taken, both in teaching, research, innovation, and many other dimensions of building a world-class university. The context for this morning session, for the benefit of the speaker as well as the audience, is continuing the tradition of interacting with some of the best minds in the country in an event of this type that also brings together some of the best minds from the student community. DAKSH is a techno-commercial competitive event, a techno-management event that is organized by Shastra every year. And because of the global pandemic, we couldn't organize it for the last 2 years. And now that we are back, we did not want to lose the continuum, and also took this as an opportunity to accelerate the momentum at a time when India is also establishing its presence very significantly as not only a country that can provide solution to its own problems, but also problems that confront the world at large. Now, that is the capacity building measure that India has consciously taken, and leadership position in some critical areas as well, that gives us the confidence that as a country, if we can collectivize our resources, there is no doubt that we will also become one of the most respected intellectual capitals of the world. And that's where the role of higher education institutions, universities, faculty, students become significantly important. The topic that Professor Kamakoti will be speaking is India at 75 and beyond. As the nation as a whole celebrates the 75th year of its independence, if we just push back, I recall an article that a historian, William Dalrymple, wrote for The Guardian when India celebrated its 50th Independence Day anniversary, 25 years back. He wrote an article that said that the story of India is not a rags to riches story, but an empire that is striking back. How true those words are as we recall that article, as we enter into the 75th year, that as a nation we have told the entire world that we have been leaders in the past for a very long period of time. And it is only in the immediate past that we slipped from our leadership position for various geopolitical reasons. But as a country, we have been handling global leadership very, very confidently. And now we are at the crossroads of taking a direction that is very uniquely Indian and something that is symptomatic of an India that has already experienced leadership for a significantly long period of time in history. As a result of which, there is something in our DNA that will definitely make our country one of the most respected countries in the global community of nations that can command significant levels of respect at various geopolitical discourses, debates, and discussions. And in that context, Professor V. Kamakoti himself has been responsible for the country as a whole achieving this unique status. He is no new face to Shastra, a person who is nationalist at his heart, at his action, armed with an engineering degree that he is fully using for nation building activities, equipped with a doctoral degree from IIT, one of the respected academic and researchers, not only in India, but amongst various other organizations, both universities and research organizations across the globe. He has been responsible for various initiatives, and all of you know about that, especially during the global pandemic. He has been responsible for steering India so that the collateral damage out of the global pandemic was minimized. And his significant role is a learning experience for many stakeholders. And drawing from that learning experience, we can't have today a person more better than Professor Kamakoti himself laying down the roadmap for India at 75 and beyond, and tell us how the educational institutions, universities, students, and faculty can play a significant role in shaping the emerging contours of India in this global landscape. With this brief introduction and the context, I welcome Professor Kamakoti again and request him to deliver the DAKSH Power Talk. Over to you, Professor Kamakoti.
Thank you very much, Professor Vaidya. It's been a very generous introduction. I certainly hope to, reach your expectation in terms of what I'm going to talk today. Yes, India at 75, we have a lot of things to celebrate, a lot of things to learn. As there goes a saying, if the present sits in judgment over the past, it has no future. If the present fails to learn lessons from the past, again, it doesn't have a future. I think this is a point where we really need to learn a lot of lessons, specifically the last 3 years, which has essentially turned out to be a big eye-opener in different aspects of how we need to shape our country, what should be our priorities, and how, as an educational institution, as a technological institution, all of us together, how are we going to contribute to the next 25 to 30 years of our nation? So when we touch India at 100, what is it that we need to deliver? What is it that we need to build? What is it that we need to develop in terms of human capacity? What are the things that would be relevant? So many questions come up, and it is our duty to basically respond to that and take proactive actions and ensure that the next generation, or the generation where many young students like you would be in a leadership position, will have a very, very, very rewarding time. I think with this noble intention, let me just talk about 2 or 3 things that we have learned and then how we take the lessons forward. Number 1, 1947, we did get what we can term as social independence. Till today, we are not, if you ask me, are we having a technology independence? The answer, unfortunately, is no. I think the next 25 years is very crucial for us to see that we are technologically independent. What do you mean by technologically independent? For everything that is especially needed for sustaining India in its present form, sustaining our country addressing the growth in population, addressing the growth in different requirements of our country. All that we need should either be provided, should either be available inside the country, or when we are going to develop such solutions across, we should be in equal par or terms when we negotiate, right? And that is something what we mean by independence. So in this context, let me take 2 or 3 very important things that we as a technological institution, IIT is a technological institution, Shastra is a university, so you have many more things than what we do. So let us basically take that forward, and I'll try to address in a little more global fashion, touching of course, technology would be my central point, but then we'll also deliberate on something more. So let me start with a case study. As Professor Vaidya mentioned, when India was struck with the pandemic, I should bring one interesting technology that we developed. And I will use that as an example to tell how an institution like Shastra, other universities can really bring up certain very great centers of excellence, which can be the authors of many large-scale systems that would be of great aid to the public. Of course, you would have guessed it. The case study that I'm going to use is Arogya Setu. Arogya Setu is a simple contact tracing application. Simple when you look at defining the application, wherein two persons, A and B, have installed them on their mobile phones. I installed Arogya Setu on the mobile phone. And when A comes closer to B or B comes closer to A, when both of them are at a distance, an ID of A gets stored in B, an ID of B gets stored in A, in addition to how long they were close to each other and an estimate of the distance. And if in the event of, say, A testing positive, all the information from A is taken into a cloud, and in which B's ID will also be there. And then B is now informed that you are in touch, you are in close proximity to someone in the past, in the near past. And so there is a chance that you may have got COVID. Please go and check. So this is a very simple definition of how a contact tracing app need to be built. But then when you start looking at the implementation of this, we need a sensor that is available to millions of people readily, because we had to roll it out very quickly. So the sensor was decided to be Bluetooth. Then we need something that is going to actuate this sensor and collect information and aggregate information. That is called an edge device. And that essentially turned out to be a mobile phone, because mobile phone is indeed available to millions. And then there was a communication that came up, that is through the 4G network. And then finally a cloud service, which basically processes this data and does all the actions that we decide. So this involved a set of discipline from, say, we need a sensor specialist who can characterize this Bluetooth. So it is a mixture of sort of, electrical and electronics engineering. Then we needed computer scientists who can write the code, collect the data and write the code. We needed communication because there was a 4G communication. And then on the cloud side, we needed large-scale database management systems. So we needed database engineers with big data analytics capability. We also needed virologists who basically could characterize these sensor interactions and say this much distance, this much time, this much proximity, and for A, when they test, how many days should I keep So many things came out from a virologist. In addition, there is the notion that we are collecting some amount of personal data. There is an extreme need for cyber security and information security specialists who ensured that this data, the entire data is protected, and they had to do a complete security analysis from a technology side. Then there is a privacy clause and other things which had to be handled from a legal side. So there were lawyers who are sitting basically saying whether what we are doing is correct. And then more than all these things, we needed, when the Honorable Prime Minister announced this, there were at least 20,000 hits on that software, right? So we needed people who can do a performance analysis of that and see whether the software can yield to many people. So there were a lot more of what you call as performance analysts and engineers for that. So, and all these things had to be achieved within a matter of a month or so. This whole software was developed within 21 days. And that gave us such a big confidence that we are able to put together a system within 21 days using completely our own engineers, our own academia, engineers, doctors, legal, and this is an excellent example of how a university today can basically be, bring about a very great software. So if you look at all the disciplines I had mentioned here, possibly except for medicine, I think every other discipline is available in, say, a university like Shastra. Of course, in IIT, we do not have the law aspect, right? But that way, as a university, you do have that. So this is something very, very important. So if we really want to go forward, we have to start looking at this type of multidisciplinary and interdisciplinary type of work. And that is something I will call Arogya Setu as an multidisciplinary work, because each one had their own intention and they all put together to bring out a software. This type of approach is extremely necessary, and one of the biggest, India at 47, that is India at 100, like 100 years from India at 2047. If we really want a country which has very much trained professionals, trained groups which can handle these type of complexities, I think the first thing that we all has to work together is to ensure that we become lot more multidisciplinary. Very clearly, what we need today is, if you say I am a computer scientist, it doesn't mean anything today. I am an engineer. That makes much more sense to me. I need to understand many things about many of, right? So I just wanted to request Professor Vaidya to see that, in a corridor in a hostel, there should not be two fellows from the same department, right? That is something you can ensure that there is some cross-pollination of ideas. So this is one very important thing. So what is happening across the world today? Multidisciplinary and interdisciplinary work as interdisciplinary education has started taking place in a very big way. If you look at many of the higher education institutions, we are now introducing courses like additive manufacturing, which involves at least 4 or 5 departments. Courses like robotics, which actually involves electronics, embedded systems, computer science, mechanical, sense, and all of them will have sensors, so there is a material science perspective there. Energy systems today, for example, it involves almost all disciplines, right? So, because including humanities, because policy becomes extremely important. When you evolve a system, how do you bring a policy for its usage? So many things are coming up, and that is something which all education institutions should aspire to. And even when it has been always an irritating question, like, no, why computer science, right? Anytime the top rankers go to computer science, there's no necessity for you to actually keep harping around computer science. You can be in any discipline and learn everything there. the question is, it is not going to become jack of all trades. Actually, you will specialize in one discipline. But what we are trying to stress is that discipline will become extremely important in these multidisciplinary contexts. It is not that there is a computer scientist cannot exist without you. And that means if you are a civil engineer, you have a big status, because the next generation embedded system problems actually comes from building automation. So a computer scientist finds a job. I'm a computer science prof, so I'm just I'm basically talking about this discipline. If a computer scientist actually finds a job, finds a lucrative job, the job most probably can be in a building automation company where you will be the core contributor as a civil engineer. So this is how the whole system is evolving, and this is one point I wanted to tell. The next interesting and important development that is happening is specifically where we are hit very badly today is on the semiconductors, right? So recently there was a flagship event by the government of India called Semicon 2022, where the government has announced a $10 billion incentive to bring up semiconductor manufacturing, packaging, etc. inside our country. So this is extremely important because ultimately we are moving to a technology era, and every technology that is going to exist, including the camera, including all, the way that from the point where I am talking from my voice and my video, my image going into this camera till it reaches you, there will be at least at least 1,000 semiconductor chips that will be playing away. Even by the time it reaches the modem in my house, you will see around 20 semiconductor chips that are in this part. So semiconductor chip for every activity today is going to become extremely important, and that is some field which we need to develop very carefully. Two things come up here. One is that we need a fabrication unit. We need packaging units. So these are all one part of the whole story here. But importantly, what we need, what as educational institutions we need to do is how do we build the human capacity, right? Capacity building is extremely important. And in this context, there is a big need for what we call as entrepreneurship in semiconductor technology, right? So today, let me give an interesting example, right? Today, building a fab is like owning a car, right? What we need here are drivers and mechanics. Drivers are those who can drive the car on a daily basis. Mechanics are those who can diagnose a fault in the car and repair it and bring it to shape, right? So one of the important things that we need to realize now that we need drivers and mechanics for the semiconductor era. We need people who understand how a fab works, who understand how the design needs to be submitted to the fabrication unit. So many people who are not very much conversant with semiconductor electronics, it is something like programming, right? Suppose I want to make a chip. I hope all of you know what a chip is. If you open your mobile phone, you'll see hundreds of them. Black things. If you want to actually make a chip, you have something on your idea, you have to describe it to a tool, a computer tool. That's called hardware description. The computer tool will take the description, convert it into a circuit with AND gates, OR gates, and sometimes it is analog design. Then we have analog digital AD converters, digital analog converters. And then from there, it actually makes the layout, it makes a mask, like, how do you make a statue, right? You make a, like Ganapati statue on Vinayaka Chaturthi day. How do you do? You just make a mask and you put mud there and you make multiple this. So similarly, there's a mask that is made and silicon is almost mud, right? So they put this and make multiple chips. So this is how the process is. So how do you prepare this design? How do you make the mask? So there's a population that is needed. Today, India has a very good design house. This is called design aspect. So India has a very good design house. We have very good, people who can convert this idea into that mask. But subsequently, after we produce that mask has to be fabricated. Then the soft version of the mask has to become hard, and then we need to actually make the chip. So there is lot of capacity building that's needed. So in that way, I think Shastra has taken a very good lead. Shastra has tied up with 2 universities in Taiwan, the Asian University and Yonsei University, and they are running a VLSI program in which 1 year the students are in Shastra Tanjavur, and the next 2 years, the next 2 semesters or 3 semesters, they go to Taiwan and they get a good industry experience, and they come back and hopefully they will contribute for our country in a big way. Right. So this is a very nice initiative. Then these type of initiatives are needed today in very large scale today, so that we make the drivers of the fab. And very importantly, we need the mechanics. So there's something called, let me tell you an example. There's something called yield in a fab. What is a yield in a fab? Of 100 chips that you make, how many of them actually work? Right? Some chips may not work because there may be something going wrong in the process. So if your yield, say 100 I make, only 50 works, you have to close the fab. And if it happens for 1 month, your fab will go into a loss. When 100 is made, at least 90, 95 has to work. That's a reasonably good thing which will sustain you. 99 should work, and that is what you should aspire for. And suddenly when a yield drops in a fab, somebody has to go and find why it dropped. There must be some small alignment problem. Just for the benefit of the audience, the accuracy to which we are working in a fab today in globally standard is 5 nanometer, 5 into 10 power minus 9 meter. To just give you an example, a well-maintained human hat is 50 micron in diameter, 50 into 10 power minus 6. This is 10,000 times lesser than, 10,000 times lesser than the diameter of a human hat. And that is the size of the transistors that are there. So this is the accuracy to which you work. So suppose you make a fab, say in Shastra, for example, and then there is a big truck that goes on this Trichy, Tanjavur highway. There's a small shake, the yield will drop. Okay, so it has to be such seismic sensitive. Seismic means not the earthquake. Even a big truck that goes on the road, there's a small shake there, it will go. So things have to be analyzed. So this type of an analysis is not just going to be some electrical engineer or chemical engineer. It can be chemical engineers because there are a lot of gases that are being used for this. There can be something going wrong with the gas. There can be something wrong going with the input wafers that come. There will be material scientists involved. There could be structural civil engineers involved, as I told you, right? That to just measure the minute level shake, minute level seismic activity. There can be, again, software issues can be there. There can be certain alignment issues. It is mechatronics, robotics, and there can be some cleanliness issue. It is about environmental engineering or monitoring or pollution monitoring. So many things. So it is not a joke. It's a real tough job. And so we need such type of mechanics who can quickly go and say what is wrong and quickly recover the fab and make it increasing. India has to concentrate on developing multiple startups who can do this fab services. And that is which extremely important. And if any of you want to be a semiconductor entrepreneur, you can basically see this is very less investment, but you need to go work in the fab, understand the fab, how it works, how you fix the issues. And once you have that control and start looking at fabs, every consultancy you take would be a learning for you, and every consultancy you go and do is a great benefit. We need such type of very high-end mechanics. And if we don't have that, again, we become dependent on other countries. You may have a fab, but the fab goes down. You have to go and say again, you are in expectation of this. the real independence come when we have the mechanics, and we have to grow that competence in this country. So this is one very, very important thing. We are now at least 20, 25 years behind in terms of in the semiconductor fabrication technology. Of course, we have a 180 nanometer technology at Chandigarh, which is still relevant. We can still make a lot of very good designs for it. And personally, I've been doing many of my Shakti processor chips there. But more than that, there is, if you want to make sophisticated chips, and that is the biggest initiative that is taken by the government to bring in fabrication technologies into the country. So this is the second important thing that I wanted to talk. And India at for 75 and beyond, we need to look at this fabrication technology in a very, very big way. Now, the last 10 minutes I have, I'm going to talk about the next very, very important thing that COVID has taught us, that is medical technology. We had, necessity is the mother of invention. And that is where we all faced. When we faced oxygen bed crisis, when we faced ventilator crisis, all of that we were able to solve because we were able to make such designs very quickly. There was one startup of IIT Madras who could quickly assemble 3,000 oxygen beds of very high quality using modular housing. Right? They made certain house structures and they were able to do. So there is I'll start again. There is a civil engineering intervention into medical technology. Right? How to quickly assemble. This is one example. There are many, many things that we can do where civil engineering becomes extremely important for medical technology. The second important thing today is that doctors should become technologists, at least learn a bit of technology that they are using and on a day-to-day basis. This is what we call as physician scientist. If you look at very carefully, 37% of the Nobel laureates across the country, across the globe, are physician scientists. Right? They are the people who got the relation between the cause and the disease. For example, sugar leads to diabetes, smoking leads to cancer. These are all basically works of physician scientists. Who are these physician scientists? They are actually doctors who also have an engineering bent of mind, a technology bent of mind, a scientific bent of mind. If you look, so this is extremely important because of the type of diseases that we are getting. Lot of imports today in terms of medical technology, and all these things could be done, and it can also be done customized to our national interest. So I've been citing this example. When the world started looking at vaccine, they were looking at vaccine which will work at minus 20 degrees centigrade, etc. In India, I don't think we can actually carry vaccines to the streets with minus 20 degrees. The world stopped when many of the developed countries stopped their vaccine and they finished it when it started working at their condition, and they are right to do that because they are interested in saving their country, and if you're interested, you can buy. Right? So that actually opens up that because our environmental situation, our DNA, our country, our type of disease we have, especially communicable diseases, lot of incidents we have here, we need to have our own Atmanirbhar solutions that will work in our country, and that is very, very important. And if you don't do that, we are in shambles. After all, health is important. Why do we earn money? For our stomach and to have a good living. And that's very, very important. This opens up a big field called health technologies. Now, as you will see that many of the higher educational institutions, technical institutions, like Indian Institute of Science, IIT Kanpur, IIT Kharagpur, IIT Guwahati, are all announced medical schools. Right? I hope Shastra also announce a medical school at the earliest. And I think that will be a very important step ahead for us. Importantly, I'm also telling that we should scrap this computer science from +2 syllabus and everybody should learn biology. That is India, the lesson that we have learned. And instead of a CBSE or a state board doing it, I think every parent, every +2 kid should realize this. At least 10th kid should realize. And in +1 and +2, if they are going for the science group, they must take biology. Understanding the anatomy of human body is very, very important. If you don't do that, then we are missing something very big. Right? There are courses like biotechnology, biosciences, biological sciences. I'm sure all universities have. If you had asked, say, a couple of years before, if you asked, we want to take biotechnology or computer science, I'm sure Professor Vedya will say, I will also vouch. Everybody would have jumped for computer science. Now I'm telling you, you'll be a fool if you want to ditch biotechnology or biological sciences too. Because tomorrow, as we see, as these things, today COVID has come, tomorrow some COVID will come, some COVID will come. The solution or existence, so today if we did not have biological scientists or biotech people, today we would not have this, even this function would not have been possible. We see at least 10, 15 people or 30 people in that hall there. It's not going to be possible. The vaccine has played a great role. We had to make a vaccine that could work in our country. And these things need this type of a biotechnology, or what we call as physician scientists, who are basically doctors taught with, it is very easy to teach a doctor engineering rather than teaching engineering to a doctor. So rather than teaching medicine to an engineer, it is very easy to teach a doctor engineer. Okay, so I think that is something very, very important. And the coexistence of medical schools in technical institutions is now extremely important. And that is something which I would like to re-emphasize at this point of time. The last one that is coming up is that I just have another 2 minutes time, is on the cyber physical systems. Everything that you see is connected to the internet today. This camera is connected, your mic is connected, you are connected, your image is connected. So this leads to what we call as cyber physical systems. Cyber physical system comprises, Arogya Setu is an example of a cyber physical system. It has a sensor, it has an aggregator, in this case, it has a sensor which was the Bluetooth, it had an aggregator, then which was a mobile phone, then there was a communication involved, and then there is a, finally there is a cloud. So all these technologies are basic building blocks. And in this context, communication becomes extremely important. Today, we are looking at 5G. I'm very happy to tell that a consortium of institutions have developed a completely Atmanirbhar 5G. End-to-end, the software is completely written. The boards are made by us, the systems are built by us, except for the chips. Everything else is ours, and we have complete control over that. So communication becomes extremely important. So 5G is taking up. The next step is 6G. And when we go to 6G, we have what we call as the satellite communication coming up. The government of India today has liberalized, space, or what we call as space commercialization, and an organization called InSpace has been launched already, and there is lot of technologies that we need to develop for space, and that is also extremely important. So, to sum up, there is a great need, there's a great expectations from higher education institutions, and all that we have talked of is more of interdisciplinary in nature. We need to develop this interdisciplinary culture or multidisciplinary culture, and we need to start exploring unexplored domains. And we have a real focus, and the government is also fully supporting these type of initiatives. The AICTE, the UGC, and the higher education institution are supporting this type of initiatives to basically take India to the next generation. And hopefully by 2047, we will be a technology super leader, and really, we will really mean technology independence in its true sense. We will be an independent country from a technology perspective. Thank you very much for this opportunity. It was a pleasure talking here. And I now leave it back to Professor Vaidya to carry on with the question and answer session. Thank you very much.
Yeah, Dr. Badri,
Yeah.
you have received questions, if you can.
Yes, sir. Yes, sir. Yes, sir. Thank you very much, sir, Dr. Kamakodi. And I received a few questions from faculty as well as some students. And for want of time, let me restrict to 4 or 5 questions only, and we'll finish the program by 12 o'clock. One has asked about Arogya Setu has bridged the people. Can technology bridge nations together, especially when technology is used as a strong source for wealth creation? Will techno-diplomacy ensure technology leadership of India similar to USA?
So similar to?
Similar to USA, America.
Oh, okay. So in this context, technology is not a rat race, right? So technology is sort of, there are unique technologies that are needed for different countries. The most important thing that we need to look at, now the word techno-diplomacy has come, we should ensure that our intellectual property are completely safeguarded. Anybody who wants to become a technology leader, the intellectual property should be with them. If I don't have IPs that I control, there's nothing to arm twist here. If you take your mobile phone today, a substantial amount or a significant amount of money that you pay for the mobile phone essentially is given out as royalty. So one very interesting development I must tell here is that in the area of 5G, we did get one of our standard essential, it is called a standard essential patent. A standard essential patent is the moment somebody makes a 4G phone and said, it is adhering to the 4G standard. The moment it is adhering to the 4G standard, there are a group of companies who have standard essential patents in that 4G, and you need to pay the royalty to them. There's no other question asked. So we also got one standard essential patent in the 5G, which is very crucial. But we need hundreds of them. We need hundreds of them. And so the response to this question is, will we become great with techno-diplomacy? The techno-diplomacy here is essentially how effectively we develop ideas that are very close to standard essential patents, and how do we protect them, right? In this context, I must also say that IIT Madras has experimented AI-based tool from a very indigenous AI-based tool from a startup in Chandigarh, XLPAT. It's a novelty checker. So if you give an idea, it will give you how many competing ideas are there, very similar ideas are there, how many competing patents are there. It will also give you what you call as the total addressable market, and all these things it gives you, so that you could quickly converge and make that idea into a very good patent. So protect your patent, and government has also reduced for all academic institutions today. The cost of filing a patent is some 1,800 or something, and there is also an expedition clause. Pay 4,000 rupees, they expedite. It will not now 7 years, 8 years, it's now 2 years. And you make all the things proper, you have a proper attorney who can help you frame the patents. Now the granting is very, very fast. So government has also made these things, DOPT I think has made these things very, very fast today. I think we need to capitalize. And so if you really want to become a technology leader, protect your ideas. Whether you sell it or not is different, but protect it first. And educational institutions, I'm sure Shastra has, all education institutions should have this what we call as IP cell, a cell dedicated for intellectual property protection.
Yes, sir. And you talked about multidisciplinary approach for solving societal problems and all. There is a question as to, is policy leadership is multidisciplinary? If yes, are their actions are adequate? If no, how do we ensure that in policy architecture, we can bring in this multidisciplinary approach?
Policy is, of course, multidisciplinary. So we are also thinking of, having a complete interdisciplinary course on policy making. See, policy in a democratic setup like India, right? So has to be very well balanced. And that's the most important thing. Suppose we come out with a policy, say suppose security policy, there is a privacy, there is a law enforcement agency. So we need to come out with something which is a balance of this. Every time we are looking at policy, any policy you take, anything like say drone policy, we have covered with a very exciting drone policy, which is now very, very, very much better than what you see in other parts of the globe. Now there is again an ease of business and there is also a regulation, right? So when we look at ease of business and when we start regulation, both have both a commercial and a technical aspect. So these are techno-commercial decisions that we need to take to arrive at this balance. And that is the real challenge. And when we want to arrive at such type of a balance, there is a need for inputs and not just inputs. I can't put a committee and get it out. There should be an appreciation and understanding and experience in working in these areas. Then only these can come together. Even for, let us say, law, like that you are looking at. Today, for every patent, you need a lawyer. And patent is completely a technical aspect. You need a lawyer to actually, attorney has to be a person who understood law. So today it is not wrong if I'm looking at an integrated 5-year program where after 4 years or 3 years, people will also do a BL. Why should it be BA BL? It can be a BTech BL, and it comes out as an integrated program. I don't know how the collegium will react if such a proposal go, but as I know, the exploratory nature of Professor Vaidya, he may go and explore this. But that's very important, and that is where you actually make a policy type of intervention. So even taking the example of Arogya Setu, the policy decision again. There is a privacy statement, which is a policy, right? There's a privacy policy, but that came by understanding mobile technology, by understanding cloud technology, by understanding security features, by understanding what it means by cryptography, by understanding. So there's a mathematics counts, but there was a crypto algorithm that was in place there. So this is where multidisciplinary approach is extremely important for policy making, and I'm sure all the educational institutions must look at MTech in policy, which should be a dual degree where the engineers basically have an opportunity to take that course in that policy, and humanities department and the legal department can look at it. And I also request Shastra can be a forerunner for this.
Excellent idea, sir. And you touched upon the semiconductor fabrications in India. So one of our EC student is asking, why is Indian industry not keen in establishing semiconductor fabs? India has been contributing to in-house research and design centers that has benefited multinationals like Intel, TSMC, Samsung, but not Tatas and Birlas of India. Why?
So the main thing, of course, the course that has been introduced at Shastra is funded by Tata. Okay, so that's first answer. So it is funded by Tata. So Tata is interested. But the main issue today so far is that the technology suddenly has seen sort of an exponential growth, especially with IoT and digital India, smart city, etc. Now there is a very big scope for people to make their own design and sell it considerably in the market. See, when we want to make a design which is a generic design, right? I need to compete with billion-dollar companies, and that was not an interest at all. But today, when we look at the market today, I need trillions of microprocessors today, and each one needs a different, different type of a microprocessor. So for that student and for benefit of all VLSI and computer science, electrical, electronics and mechanical students and almost all, please go and search for domain specific architectures. Right? Today we are looking at very simple tiny things that I can make here. I can sell it in millions, I can make profit. Right? So that is the real different market that has suddenly opened up. And when it opened up, that is where we feel that we need fabs today which can make these devices and sell these devices. So that is why suddenly the Indian industry also has woken up. And secondly, there is a dependency abroad, which is actually killing this. The third important thing is security. When we get it as a black box, we don't know what is inside. So the chip that comes out, I always say this in the digital design verification course, we know what it does, but we know that it will do what we want it to do. But we do not know it will not do what we don't want it to do. Correct? So that's a question. That's a very difficult thing. And if you get it in a black, it's really black in color and it's a black box. And security becomes extremely important. And today, as and when these electronics are coming much closer to you in terms of deployment, you have a smart watch, fit watch, everything today. So it tells you which hotel, what you are eating. It only says that it knows still you are eating. It doesn't say masala dosa. That's something. And moment that bill also comes on some GPay, now we will know you have eaten masala dosa also. Right? So when it becomes very closer to you, I think that's where security becomes extremely important. So for all these reasons today, world has realized that they need to have something on their own. And that is where, the sudden growth of interest among the Indian industry has come up. And I'm sure within a couple of years or 3-4 years, we will have our own fabrication setup. On the design side, we are doing extremely well. A lot of designs are happening in the country. A lot of indigenous designs are happening inside the country. Only on the fabrication and packaging, we'll surely get it up within very short time.
Thank you, sir. There's a question from a law student. You talked about technology independence. For achieving that, don't we need academic independence? As a director of IIT, what is your comment on academic independence?
Academic independence is something that, I still remember my 2004 counseling. There was one kid who came to me and he said, I want to join. I asked, the counseling started, and there were two elderly people standing in front of me, one male and one female. They said, sir, for this rank, what is the course we'll get? Then I said, where is the kid? Kid was standing some half acre away from me. Call that kid. I made him stand next to me and asked him, hey boy, what do you want to do? That time we were introduced some engineering physics. He wanted to do physics. Okay, he started saying engineering, The mother went and pressed his mouth and said, computer science choose. Say computer science. Okay. So that is the dependence which kids have when they want to select these courses. So the first dependence comes from their ranks, right? Even in Shastra, I think Vaidya also puts you, according to rank only you allocate. Now that is a dependence. Okay, I have no other, I got this rank. On previous day before the exam, I looked at some IPL match. Next day morning, I didn't do it well. I was sleepy and missed the 2 questions. You go well down in the rank. But there's no way. We have to rank because we have a limited number of seats, and how do we select? Now, subsequently, okay, because of that, you get into your course, fine. Still, that course is relevant because of your multidisciplinary thing. So you have subsequently 2 years down the line, or many of our institutions have now made only 50% of the credit to that karma that you have done. The remaining 50% still it can be opened. So in these 2 years, if you do well, you can actually basically go and do a lot of interdisciplinary courses. A lot of courses will be there. Interdisciplinary courses you can do. And then learn the other aspects. So there are many, every student at IIT today reads data science. In science, they do, data analytics, they do machine learning. They get into an AI expert. with the expertise of their field. And then now this gives them the independence to start analyzing that core group of engineering from an artificial intelligence and data analytics perspective. How to improve some of the systems that are part of that core curriculum using AI and data analytics. So this independence they get. So by the second year or third year, they get an opportunity to do some other minor or even major, now almost 50-50. That is the independence that the multidisciplinary approach gives. So this is my answer to the student's question.
Thank you, sir.
Yes.
And there is a non-technology related question relating to you personally. See, when the IITs and the premium institutions are used as a springboard for jumping to foreign countries to get a handsome salary, what made Dr. Kamakodi to stay in India? What is the source of inspiration? What made you to stay in India? And that is what the question from one of the students.
Oh, well, one thing is my Guru Paramacharya of Kanchi actually told me not to cross the sea, not to cross the borders of our country. Stay here, and he said one day you will contribute. You may be recognized, and if you are not recognized, you will retire with a good contention that you have done something great for the country. Looking back, I'm just following his advice, and looking back, I also feel that some people said we were having some statements at those point of time in 90s in some big universities that I need not even go out of the university and I can become world famous. I want to try it in IIT Madras. I don't want to get out of IIT Madras and see if I could become world famous. If I become famous, then I have a very good example to set up. And if I don't become famous, some Kamakoti, some crack fellow did something, nothing happened. So it doesn't have a negative impact, but if I make, it will have a positive impact. Now, time will tell whether I'll make a positive impact or negative impact. But certainly, my staying in the country completely, like I don't have a passport, I stay here, has made me realize what it means to develop a system in the country. What Atmanirbharta essentially means, the full definition, what it means to achieve Atmanirbharta. I feel I am at least much equipped to talk about that because I have really gone through a major project like Shakti end to end. We have seen many such projects which we have taken from scratch and see how to do it extremely. It's just sitting in the country with whatever knowledge we have gained from the Indian system and the exposure that we have of what it means to bring it. And that's, I think, is now becoming very important for me. When I try to take my institute into the next, what is possible in the country? I know I have a clear idea of the possibilities. So when I make certain decisions, it helps me very much what is possible, what is not possible, how long it will take, how to get it done. So many interesting things have come up. So all saints, the word they say will have thousands or millions or infinite meanings. I am started realizing something from that advice. And I'm sure I'll realize a lot more as we go. And every DAKSH that you call me, I'll share more experience as I gain more. Thank you.
Thank you, sir. There's also a message that if you listen to the Guru, definitely you will succeed one day or other, as our Guru Paramacharya has said. And before we conclude, I have my question as the last penultimate question of this session. And India is boasting of demographic dividend. On the other side, we have a huge skill shortage also. Given a chance, if you are given a policy, given a chance to make a policy decision, what one decision you will make it to see the demographic dividend really become dividend to India instead of a liability?
No, the point here, we'll only talk about skill, right? Skill is what we want, right? So I still remember there was a great king, Parikshit Ramavarma, who was from Kerala. After the union of all kingdom in India post independence, he was made the chairman of Sanskrit Commission. He was a great Nayayika. He was a logician, right? So the first meeting he asked, what is the need for this commission? The question was not to propagate, promote, and keep and show posterity and pedagogy, all these things. Then he simply told, "Enda ஒரு சம்ஸ்கிருதம் விருத்தியானனா எல்லா வாத்தியாரும் ஒழுங்கா சொல்லி கொடுக்கணும், எல்லா குட்டிகளும் நன்னா கத்துக்கணும். இதுக்கு எதுக்கு கமிஷன் அப்படின்னு கேட்டேன். You got it, right? Today the only message I have is, let all teachers, all of us, put our heart and soul and teach well. And all students, when they come to class, without WhatsApp and Facebook and other distractions, no distractions in social media, let them all give undivided attention and learn the subject. That's all. If these two things are going to happen, our problem is very simple to be solved. This is a very simple solution. Let us teach well, let them learn well, and I think we'll make it great.
Okay, thank you, sir. Though I have many other questions, for want of time, let me stop here. And I'm sure that you ignited the minds of several young minds here in Shastra across the country also. We are really privileged, honored to have you amidst us. And I know that a person of your stature, for 40 minutes of sharing all your brilliant ideas, it's not possible. But we would like to see you in person, and in many other opportunities, we would like to invite you, see you at our campus. We want you to continue to support, guide, mentor Shastra students and faculty. We are really happy. And I take the privilege of thanking you. Thanks is a very, very small word for all the time that you spared and the knowledge you have shared also. And students of DAKSH, in fact, you are very, very privileged. The DAKSH gets certified today. The quality of DAKSH is being certified by the presence and the sharing of knowledge by Dr. Kamakodi today. And not only is a great scientist, all of us know that he is a great patriotic Indian. So more than a scientist, now we are all getting a message that we have to be a patriotic citizen of this country also. And whatever you spoke in 40 minutes, I'm sure that will have an impact for next 40 days in the minds of the teachers and students or any audience who are listening here. So with this, without taking further time, I know that you have many other commitments also. I thank the speaker, Dr. Kamakodi, on behalf of the management, faculty, students of Shastra. We would like to thank the speaker for sparing his very valuable time. Thanks to our Vice Chancellor for giving this opportunity and arranging your talk to the Shastra students. And as I said, there cannot be a better person can be called for this kind of tech talk. And he has done, as usual, done a great job. Thank you very much to our Vice Chancellor. Thanks to all the faculty, students, student organizers for brilliantly organizing. Many of them are watching. I thank all the virtual audience also. Thank God for this wonderful opportunity. Thank you, everyone.